We are living in the age of generative AI, in which it is ever so important to understand the fundamentals of every language that we code in. Where, because AI is generating the code for us, it is ever so important to understand the basics and to understand and interpret the code. In the past few weeks, I've been releasing 1-minute videos where each day I cover a different concept of Python in these videos. I have received a request to compile all of this into one video, so I have taken the effort to edit all of these shorts into a single video so you can follow along and have an overview of the fundamentals of Python used for data analysis. I have used Jupyter Notebook for all the coding examples so you can follow along with me, and if you want to know how to install Jupyter Notebook and create a Conda environment for yourself, I will leave a link in the description to a video in which I covered that, and I'll also leave a link in the video here. So let's see what we'll cover in this video series. So by the end of this video, you will have a knowledge of the following concepts. We will take a look at the overview of Python and what it covers. We'll take a look at object classes and functions in Python and how they work. We'll have a look at functions and methods in Python and how to use them. We'll take a look at implicit and explicit type conversion of different variable and data types in Python. We'll take a look at if, else and elif control statements and how to use branching logic. We'll have a go at while loops and why are they used and how to use them with coding examples. We'll take a look at iterables in Python and what do they mean. We'll take a look at for loops and how do they work in conjunction with iterables, and we'll take a look at indexes and string operations in Python. I'll keep on extending this concept series, and I'll be making more and more videos which I will compile into longer series. So now let's get into it and take a look at each concept, one concept at a time. Python is an object-oriented language. It consists of classes, objects, and functions. Classes are the template of the functionality that you want to capture. Objects are the instance of the class, and functions perform actions on the attributes within the objects. They are encapsulated within libraries or modules. Objects contain functions, and functions take in arguments as parameters and have return types. Not all functions have return types. Objects also have attributes which maintain the state of the class. Let's take a look at a class. A class has an initialize method and self with the first attribute. They also have attributes, and a class can also have functions. Now let us run this code. I create an instance of the class, and I can access the attributes, and I can call the functions to perform some action. Let's take a look at the difference between class attribute and object attribute. I've assigned the class attribute here, and I've assigned the object attributes here. I've also created a method that will attempt to alter the object attribute as well as the class attribute. Let me run this and now create an instance of the class. Now let us access the object attribute. You can see the object attribute is Ferrari because I've set it in the constructor here. Let's access the class attribute. The class attribute is still car because I've set it here. Now let me call this method and attempt to alter the attribute values. I call this method, and now let me check the object attribute. The object attribute is changed to BMW because it is set here, but let's see if the class attribute has changed. And I access the class attribute, and the class attribute is still same, it remains unchanged as what is set here in the class. In Python, we have objects, classes, and functions. But have you ever heard of the term methods and wondered how are they different from functions? Functions help you modularize your code in Python. Let's take a look at a simple function that takes in two numbers as arguments and returns the sum of both the numbers. I can run it, and I can see in the cell the output is there. Now if I include the same function as a part of a class, it is now referred to as a method of this class. I can run this class, and now I can create an object of this class, and I can access it by using the dot operator. Let's take a look at the difference between implicit and explicit type conversion in Python. Let's assign 1 to this variable and let's run this. You can see it's of type integer. Let's assign 2.4 to this variable and let's run it. You can see the type of this variable is of float. Now let us add these two variables together, and we see the total is 3.4. If we type the type of the total, we get it's of float. So Python has implicitly converted this variable into a floating point object. So now let us try with the same with string. We try to concatenate string with the total variable. Here we get an error because Python cannot convert a floating point variable into a string variable. So now for this we have to do explicit conversion, where we convert the variable ourselves. Now we run it and we get the answer. If you type here, this is a string variable. The if, else and the elif statements are used to implement conditional branching in your code. This function classifies the users based on their age. It has multiple conditions. Hence, I can implement this using an if and multiple elif statements and a final else statement. The indented blocks of code beneath each if or elif statements executes when the corresponding expressions of an if or elif statement evaluates as true. If not, the indented code block under the else statement executes. Let's test this function by giving it a few values. While loops in Python are used to repeatedly execute blocks of code until the value of the expression in the while loop evaluates to true. In this function print numbers, we take in an input from the user, we set the counter equal to 0, and while the counter is not equal to the number entered, we print the counter and increment the counter for each iteration. Once the counter becomes equal to the input number, the while loop exits. Let's execute this and call this function. For loops in Python are used to iterate through a collection of objects contained in an iterable or iterate through a sequence of numbers generated by the range object. For each iteration, they execute the block of code contained in the for loop. Let's take a look at this example. In this example, the for loop iterates through the numbers contained in the list object and for each iteration executes the print statement. In this example, the for loop iterates through the numbers generated by the range object and executes the print statement for each number contained in the sequence. Iterables are objects in Python that can be iterated upon using a for loop. Let's take a look at an example of few iterables in Python. A string is an example of an iterable, which is a collection of characters. This is an example of a list object, which is an iterable, and in this case a collection of integers. Similarly, examples of tuples, a dictionary object, and sets, which are also all iterables. Let us take a look how we can access iterables in Python using a for loop. For variable name in iterable, this will iterate through every object in the iterable and assign it to this variable, and you can perform some operations on the variable for each iteration. Let us execute this. And similarly, for each character in the string example, each character will be assigned to this variable and you can perform operations on each character for each iteration. Indexes in Python are used to access a single object or a sequence of objects from iterables. Python follows zero-based indexing, which means that the first item in an iterable is located at the 0th index. To access the first item, I can use the following command. Similarly, if I want to slice the iterable and access from item at position 1 to position 3, I can use the following command, where 1 represents the item at position 1 and Python does not include the end position but the n-1 position. I can access the last item in the index using -1, and since string also are type of iterables, I can apply the same operation to any iterables like string or tuples. Let's take a look at some string operations in Python that can help you manipulate text data during data analysis. Strings are immutable data types, which means you cannot alter them. You can only alter them by reassigning them to the string variable. You can do addition operations in string. You can do multiplication operations in string. You can access each character in the string sequence by specifying the index. You can extract a portion or a slice of a string. You can find the position of any character in the string using the index method. You can use the find method to find the position, index position of any word in the string. You can use the partition to partition the string into a 3 tuple. You can split the string into a list of string text. You can join a list of strings using the join method. You can format the strings using the f strings, and you can also use the format method here. If you have a string which is written on multiple lines, you can use triple quotes.